Good day, class. We'll continue sa ato ang discussion on still on the topic this is a new topic which is methods of analysis. And under methods of analysis, we have the nodal analysis and the mesh analysis. Okay. So as a review, we already discussed and understood the fundamental laws of circuit theory. So we have Ohm's law, right? So I recall that, oops. Okay, sorry about that. So you already understood about Ohm's law, and also we discussed Kirchhoff's law. Okay? Under Kirchhoff's law, natay natawag na KCL, that's what we call it, Kirchhoff's current law. Okay, Kirchhoff's current law is the conservation of charge and that no charge accumulates at the junction. So the total sum of the current entering and leaving a certain node or junction should be equal to 0. In other words, the total current entering a junction should be equal to the total current leaving out of the junction or node. Then we also have the KVL, okay, the Kirchhoff's voltage law. That is the sum of all voltage in a loop, okay, katong independent na loop should be equal to 0. That's by virtue of conservation of energy, okay, or voltage. Okay, so having understood these laws, we are now prepared and ready to apply this one. So apply this, kaning basic ng mga laws. Not only that, but also Ohm's law. Okay, apply this one to so that we can develop a more powerful techniques for circuit analysis. Okay, so we have the nodal and the mesh analysis. Okay. So these two techniques are very important for this particular chapter and should be regarded as the most important chapter actually in the electronics na book or any electronics na book. Because if you are able to understand this concept, okay, it will always recur and will always be applicable to much more complicated mga topics sa electronics. So the very foundation of it is kaning Ohm's law, Kirchhoff's, and also the methods of analysis. We have the nodal and the mesh. Okay. So with these techniques, kaning duha, kaning nodal and mesh, we can analyze any linear circuit by obtaining a set of simultaneous equations. Could be 2 equations, 3 up to n equations. Okay, and then we are going to solve the unknown variables there. It could be voltage, it could be current, and then using any mathematical tools that you have or that you know or at your own disposal. Could be the Kramer's rule, katong magamit ka og basket method about matrices, and a much more efficient way to solve sets of simultaneous equations by using a software, for example, or programming language such as MATLAB. Okay, mas dali na siya ma-solve na to ang mga unknown na mga variables. So we will see some examples later on wherein mag-apply ta og MATLAB na language in solving that one. So more on that later. So also in this particular chapter, we will be doing a circuit simulation sa computer. Magamit siya og software program nga para ma-solve ang inyong circuit. So let's say pangitawon ang nodal voltage or even current at a particular branch. So that would be possible by using a computer software or a circuit simulation computer software. So we'll be using PSpice. So ato nang gamiton. Okay, I think this is free. PSpice. So this is downloadable na siya. So you can download that one. And we'll see some examples of certain problems where PSpice will be used later on. Okay. So let's begin with the nodal analysis. Okay. So nodal analysis, it provides a general procedure for analyzing circuits using node voltages as the circuit variables. So ang pangitaon diha ng mga variables kato mga nodes. For example, if you have 5 nodes, then you have 5 anodes nga imuhang atong pangitaon. And then we'll be choosing node voltages instead of element voltages as opposed sa katong nagamit ta sa Kirchhoff's and Ohm's law. Atong gigamit dito is ang voltage man sa element din mismo sa resistor. For this case, ang junction itself or ang node. And to simplify matters, we will assume in this particular topic that circuits do not contain voltage sources. Okay? Then later on, ato ang i-consider ang naay mga voltage na sources. Okay. So in nodal analysis, we are interested in finding the node voltages. So given a circuit with n nodes without voltage sources, so the nodal analysis of the circuit involves will be taken by just using 3 steps. Okay. So sa first step, we should select a node as a reference node, and then mag-assign din taog voltages V1, V2, and so on sa remaining mga nodes nga itong i-assign. And the voltages are referenced with respect to the reference node. So, usually, ato ang reference node is ang ground. Okay, and that is taken to be 0. The next step would be ma-apply taog KCL, katong Kirchhoff's current law. So, ma-apply taog what are the currents entering and leaving at a particular node. So, ito ang siya gamitin. And then, we will be using Ohm's law to express the branch currents in terms of node voltages. Lastly, we will solve the resulting simultaneous equations na ito ma-obtain to find the unknown node voltages. Okay? So, as what I've said kanina, first step yun na tumuhaton is mo select ang reference node, and that reference node is commonly called the ground since it is assumed to have a 0 potential. Okay? And a reference node is indicated by any of the 3 symbols. Pwede ingon ani ang kuan. Reference node symbol ana siya arrow, or pwede po ana ground, or pwede po ingon ani. Okay, that's our reference node. Okay, so this is a common ground, this is a ground, and this is a chassis ground, or chassis. We call that chassis ground. Okay. So as we have selected, once na ma-selected na nato ang reference node, we assign then a voltage designations to non-reference nodes. So consider this example. Take a look at this example here. Okay, so if you take a look at this one. So our reference node is clearly kani. Okay. So So this is our reference node. Okay? And our non-reference node are this. Non-reference node 1 and the non-reference node 2. So we will call this one as, say, V1. And then we have V2. Okay, so natay duha ka non-reference node. Then the second step, we will apply a KCL. Okay, so for the KCL, kailangan nato siya i-determine unsa ang mga currents ng mga possible na moagi sa kaning circuit. Okay, so we can have so we can assign a current variables. For example, let's say sa kaning case, this is your I1. This is na current mo agi diha. Of course, na yung current diha, and we will label it as I1. Then we have I2 here, and then here we have I3. Of course, kaning capital I2 that's already given. So let's say na siya value diha. And also capital I1 kani siya nga part na siya a specific value ngayon ihatag. Okay? And then, after that, we will apply KCL sa node 1 and node 2. So, for node 1, we have, on the left side sa equation, atong ibutang ang mga currents na ni-enter that will be positive. Okay. So, ang current na ni-enter is only I1. Okay, wala nilain I1. And then, ang mga currents po na migawas sa node, that would be placed on the right-hand side sa equation. That would be I2 plus I1 plus I2. Okay, small I1, small I2. Next, we have node 2. So the same concept will be used. So in similar manner, we have the currents entering the node 2. We have I2 and small I2 equals the current leaving at that particular junction. We have I3. Okay? So muna itong equation na kailangan. Next is, we'll be using Ohm's law to express this one, to rewrite this equation. So we'll be using Ohm's law. So use Ohm's law so that mahimo ng siya sa node 1. Sa node 1. Using Ohm's law, mahimo na siyang ang imong i-express sa anak atong mga small nga mga i's dito. So we have I1, retain na siya, then we have I2 plus. So ang I1 nimo is magamit ang Ohm's law. So I is just equal to V over R. Okay? So that would mean musugod ka sa higher potential than lower potential over R. So ang formula is this. So we have I, so we have V higher minus V lower over resistance. Okay? So if you look at this figure, so we can see here that ang ato asyang i-assume, it's in the picture already, that node 1 is at higher potential because the current is flowing here. So we have a higher potential, then this is at lower potential, ang V2. So we would say ang I1, okay, at node 1 as we have V1. Okay. So, since ang I2 man ito siya, no? Ang I1 is naman sa ubos padulong, right? So, ang I1 is from high potential, that would be V1 minus the lower potential is at the ground. Okay? So, that would be 0. So, pwede na siya walay minus 0 diya. Then, that's over R1. Okay? Plus, ang I2, I2 would be V1 minus V2 over R2. Okay? So that would be the equation now using Ohm's law. So ang small na I, na-express na siya in terms of V over R, or in terms of the node voltages. Now for the node 2, okay? So for the node 2, we have I2 plus, so ang small I2, the same hapon, we have V1 minus V2 over R equals, ang I3 is V2 minus 0, it's just V2 over R3. Okay, so nanatay sets of equation. We have this one and this one. Next sa buhaton is ito siya i-simplify. Okay, so we will collect all those variables containing V1 and all those variables containing V2, and then sa right hand side will be the constants. Okay, so kanin siya, that would be to i-combine ang kanang V1. So we have 1 over R1 plus 1 over R2. That would be V1. Combine mo siya. Okay. And then we have plus, minus naman siya. So we have minus 1 over R2 V2, okay, equals I1 minus I2. Then kani siya, that would be 1 over R B1, right, minus, so pwede 1 over this is R2 na siya, so 1 over R2 plus 1 over R3 B2. Kaya ako na siyang simplify. And I have negative I1. Okay? I1 I know. This is I2. Sorry about that. So this is negative I2. Okay? So the reason nga ako siya i-collect ang tanan B1 and B2 because mo na siya ang mga unknown variables. So we have two unknown variables, B1 and B2. So this is a set of simultaneous na linear equations. So we can solve this using elimination method, substitution method, or we can use katong matrix. Okay? Magamit ang matrix. Especially if tulunan na siya ka equation or upat, mas applicable na dayon itong matrix na type of equation. So, setting this into matrix form, we have this one. 1 over R1 plus 1 over R2. Okay, so ano siya? Then, negative 1 over R2. Then, dito sa ubos, we have 1 over R1. Then, negative, 1 over R2 plus 1 over R3. This is V1, V2. Okay, matrix formula siya. Sa right hand side, we have I1 minus I2 negative I2. Na. Okay? And sometimes, ang ginagamit sa uban is, instead of writing 1 over R, they use the conductance. So, ang conductance is G equals 1 over R. So, sometimes, it is written as this one. Wala na sila, di ka maglibog ito, wala siya reciprocal ba. So, this could be G1 plus G2, and this is G1, negative G2, negative G2 plus G3, in terms of conductance na sila. So you have V1, V2. This is I1 minus I2. Okay. So dali naman na siya isolve na using Cramer's rule or using MATLAB. Sa MATLAB, isa naon naman na siya. The general form for MATLAB in handling this type of expression is, let's say you have A, X equals B. Okay, in this case, ang A is kana, ang X is kani, and ang B is this one. And then our goal is to find X. The variable X is a vector V1, V2. So to solve for X, in MATLAB, you just had to simply input X equals A, ana, then B. Makuha din mo ang X na siya value nga duha ka buok. Let's say V1 and V2. So na siya specific value. So you are then able to solve the unknown variables V1 and V2. Okay, so na-establish na nimo, na-solve nimo siya. But before that, you need to establish first your sets of equation by looking at the figure like this one. Okay. Okay, let's have an example. Consider this one. Let's take a look at this example. Okay. Consider this circuit, and then calculate V1, calculate V2. Okay. So, pangitaon na to ang node voltages, or the voltages at the node. Okay. So next is, we need to establish first asa padulo ang mga currents. Right? So for this particular example, okay. So we will have to, let's say this is I1, and then this is I2, and then kani I3. Okay, more man na atong kailangan, di ba? So yeah, we've set up the following currents. Next is, we will be using ang atong method, ang steps sa pag-solve sa kaning problem using Nodal Analysis is to apply KCL at node 1. So, apply KCL at nodes 1 and 2. So consider node 1. Okay, so node 1, sa ato ang kuan diha, currents leaving and currents incoming. Okay? So ang current kani sulod is just 5 amp. Okay? 5 amp. 5 amp equals, matilaing current kung sulod, 5 amp lang. And then currents leaving, we have I1 plus I2. Okay? How about node 2? Okay? So sa node 2, we have the currents leaving and entering. So ang current nga ni enter, we have I2. Wala nilain. O na pa? We have plus 10. Right? Then currents leaving, we have 5 plus I3. Okay? So I think that's it. After that, we apply tag Ohm's law sa both node 1 and node 2. Okay, so let's simplify instead ng 5 amp, let's say 5 na siya nga number. That simplifies 5 amp. So 5 equals, so ang I1, take a look at I1. So may agi siya din nga branch. That will be V1 minus 0 because ato ang reference node is the ground and the ground is 0. So we have V1 over 2. Right? So we have V1 over 2 plus ang I2 nimo, so we have V1 minus V2 over 4. Correct? So sa node 2, we have V1 minus V2 over 4 plus 10. Actually, mas-simplify na siya. Ito na i-move ang 10 diha. Let's say we have 5 plus ang I3 nimo is just V2 over 6. Okay? So, kana lang. Importante kayo siya ang pag-set up sa equations sa nodal analysis, sa node 1 and node 2. Then, we have to simplify this one. Collect all the V1s and the V2. So, we have 1/2 plus 1/4. That is P1 minus 1/4. V2 equals 5. Alright? Then simplify na siya. We have 3/4 V1 minus 1/4 V2 equals 5. How about sa right hand side? Sa right hand side sa node 2. So we have 1/4 V1 minus 1/4 minus 1 over plus 1 over 6 V2 equals 5. Right? So this would be, ito is simplify. So we have 1/4 plus 1/6, that is 5 over 12. V2 equals 5. Okay? So, kana siya. Then, pwede na ito siya simplify pag further. Kaya itong bangtangon ang kaning fraction. So, we just have to multiply this by 4. So that we get 3V1 minus V2 equals 20. And we have this one sa pitas at multiply yan all 4. Right? So we have V1. Hindi siya 4K. Hindi siya ma-simplify. Ito multiply yan all 12 para ma-wagtan din siya. Okay, so we have 3V1, wagtan ang nilaman dito. 3V1 minus 5 V2. This is 5 V2. equals 60. Okay, so natin mga equation. This is equation 1 and equation 2. So mahitabuan ato siyang i-solve using substitution or elimination method. Okay? So let's say mag-solve tayo using substitution method. So, using substitution method, pwede mo na siya nga B2 is what? 3B1 minus 20. Right? Pwede substitute nimo sa kanina equation, substitute nimo diha. That would be 3b1 minus 5, 3b1 minus 20 equals 60. So we have 3b1 minus 15b1 plus 100 is equal to 60. Right? So we have negative 12b1 is equal to negative 40. Minus 3. 12, 16. Okay, so correction guys, na ako na mali diri. Kanina part ba? So you have 10 minus, so that would be, ako siyang ibalhin sa siya nga part. So nagtabuan ni is akong ibalhin sa pikas, so this should be negative 5. Negative 5 na siya. Okay? So that would be negative 5 din siya. Negative 5. So this is negative 60. Ano? So pag abot din sa obos, so this is negative 60. Negative 60, negative 60. So this would be what? Negative 160. And V1 should be 13.23 volts. So muna siya sakto. And then we have V1. So V2 would be mura isubstitute balik. So V2 would be 20 volt. Okay. Maka na. Also, we can use the matrix method. So itong establish ang matrix method. So we have this equation and then this equation. We have 3, negative 1. We have 3, negative 5. Nasa. We have B1, B2 equals 20 and then negative 60. Okay? So, kanina part, pag-solve na to, itong i-try gamit ko sa MATLAB. So, let me open my MATLAB first. Nag-loading pa ang MATLAB. Pause. So here, ano siya ang MATLAB. Sa tumuhaton is i-input nato ang kaning sa matrix. So ato na input ang kaning matrix and this matrix also. Okay? So, para makita na to. Oops. Asya. So let's say ang A na to is to siya establish. We have 3, negative 1. Second row, we have 3 and then negative 5. Okay, sunod is ang B. We have 20 and then negative 60. Okay, anak man na siya. This is A, this is X, and this is B. So to solve for X, we have A inverse B. So sa MATLAB, anaon na siya. X equals A, and B. So we got this one. So it's a vector, ang X. So ang pinakauna nga value na corresponds to B1, which is correct. Tara. And ang B2 is 20 volt. Okay, so masayon siya, right? So kani atong gamiton from now on, okay, especially if we have 3x3 na siya ka matrix, meaning 3 unknowns, or 4x4, or 5x5, and so on. It will be a lot easier to handle that one using MATLAB. Okay, I hope that is clear. Okay, so having solved the B1 and B2, so nakuha na po nimo ang mga currents. Okay, so we have I1 and I2. So ang I1 nimo is just B1 over 2, right? Now, ang B1 nimo is 13.33 man to siya, divided by 2, so you get 6.67 ampere. Then yung I2, ano man na, B1 minus B2 over 4. Okay? So we have 13.33 minus 20 divided by 4, that would be negative 1.67 ampere. Then ang imong I3, we have B2 over 6. Okay? B2 is 20 divided by 6. That would be 3.33 amp. Okay, so dili na naman tayo negative na current, we have I2. So it shows the negative siya. That means that the current flows in the direction opposite sa itong gi-assume. Okay, so ang current di ay nga I2 is actually, ato naman yung gi-assume ang direction sa I2. Actually, paana siya. This is I2. So sa ito atong value. Negative would mean opposite ang atong direction na itong i-assume. Okay. So, mura na siya. Okay, so that will be an example sa how to solve a circuit using a nodal analysis. Okay. Next is, pwede mo try of maybe another example. Medyo taas-taas naman siya. Anyway, let's try. So let's consider this example. Nah. Okay, so determine the node voltages. How many nodes? We have 3. So we have V1, V2, and V3. Next is we will assign voltages at the assigned currents. Okay, after assigning node voltages, okay, muna siya yung V1, this is V2, and then this is V3. Mag-assign din taong current. Okay? Let's say, kanisiya is I1. Kanisiya is I2. Okay, sorry. I2. This is I3. Okay, I think muna. The rest kay nahatag naman ang mga current. You have IX, 3 and then you have 2 IX. So simple na dyan ang process sa nodal analysis. We will apply KCL at every junction or node. Okay? So let's take a look at node 1. Oops. Okay, at node 1, we have 3 equals 3 ampere ang disolute. Tapos ang gawas kay I1 plus IX. Okay? And then sa node 2, we have IX equals I2 plus I3. So node 3, we have I1 plus I2 equals 2IX. Okay, I hope that is clear. Tanawan ninyo sa figure. KCL na siya. After that, mugamit ta og Ohm's law para ma-express na to ang tanan I in terms of the V over R or the node voltages. So we have 3 equals, take note sa I1, we have V1 minus V3 over 4 plus ang IX nato is V1 minus V2 over 2. Okay? Then, let's take a look at node 2. So, ang IX is same hato. We have V1 minus V2. Oops. Na. Lag. Anyway. V1 minus V2 over 2 equals V2 minus V3 sa I2 na siya over 8 plus V2 over 4. Okay? Tuliin mo ba sige lang yung mga kuan. Okay. Uy, naglag. Na. Again, I1, so sa node 3 na ta, node 3, I1 would be V1 minus V3 over 4 plus ang I2 na to is V2 minus V3 over 8 is equal to move carry 1 space I3. Yeah, ang I3 na to would be have IX isa. Sorry. Have 2 times V1 minus V2 V1 minus V2 over 2. Okay? So, wala na siya natin tulo ka equations. Pero before that, siya i-simplify. Collect all those similar variables, I1, I2, I3. V1, V2, V3, I mean. So, we have 1/4 plus 1/2. Okay, we have V1 minus 1/2 V2 minus 1/4 V3. Alright? Equals 3. Simplify mo na siya, no? Okay, so this is 3/4 mo na siya. Okay? So, ano siya? Ito i-simplify, this becomes oops, what's lag? Okay. So, we have 3/4 V1 minus 1/2 V2 minus 1/4 V3. Simplify na ito na siya og 4 para mawagtang ang fraction. We have 3V1 minus 2V2. Oops, kasi na ako yung mali rin yun. Sakto. 3V2 minus V3 equals 12. So we have this equation na i-box. Uy, mag-log na pagpili. Na. Same thing happens here. Ito siya i-simplify. So we have 1/2 V1. Okay. Then we have plus minus sorry, minus 1/2 plus 1/8 plus 1/4 V2 na siya. Ibalhin ako sa left hand side tanan. Plus 1/8 V3 equals 0. Alright? So, simplify na siya. We have 1/2 V1 minus, I'm gonna use calculate, 1/2 plus 1/8 plus 1/4, that would be 7/8. 7/8 V2 plus 1/8 V3 equals 0. Nga, mag-multiply taan na ang 8 para ma-simplify. Naatay natin 4V1 minus 7V2 minus plus V3 equals 0. Okay? So we have this the second equation. Finally, we have the third equation. Okay. So if you do the algebra here, you will get you have 2b1 minus, you can do this na yung sa inyong we can try to solve this one and confirm if mao ba ni siya. Minus 3b2 plus b3 equals 0. Okay? So, naatay tulo ka equation. So, atong goal is we have to determine v1, v2, and v3, and then maka-determine din ta sa currents I1, I2, and I3. So, ato siya establish ang matrix for this. Okay? So, we have 3, negative 2, negative 1, 4, negative 7, 1, 2, negative 3, 1. Okay, I hope nakapalo lang mo. Natin tayo B1, B2, and B3. Okay? The right hand side, ang katong mga constants. We have 12, 0, 0. Ano po din mulag ng circle? Tara. So, 12, 0, 0. Okay? And that would be a lot easier to solve using MATLAB. Okay? So, atong gamitan ng MATLAB. Tara. So, atong i-clear sa ang cache. So, atong establish ang A. Naman na. So, input ato ang mga values. We have 3, negative 2, negative 1, semicolon, 4, negative 7, 1, semicolon, 2, negative 3, 1. Okay? And ang B nato, 12, 0, 0. Na. To solve for x, at ang mga b1, b2, b3, we have a backslash b. Okay, that's it. We have v1 is 4.8, v2 is 2.4, and v3 is negative 2.4 volts. So, na siya kasi. So, v1 is 4.8 volt, v2 is 2.4 volt, lang isa. V3 is negative 2.4 volts. Okay? Box. So once we have determined V1, V2, and V3, automatic na ma-determine dahil na to ang mga currents. We have I1, Ix, I2, I3, and so on. Okay, gamit lang atong Ohm's law. Kanina naman na. For Ix, we have V1 minus V2 over 2. I2 is V2 minus V3 over 8. I3 is V2 over 4. Ang I1 na to is kani V1 minus V3 over 4. Okay, so na-solve na dahil nino sila. Okay? So next would be, how about if we consider a nodal circuit na naa siya voltage sources. So we will have nodal analysis with voltage sources. Okay, so we have nodal analysis with voltage sources. Okay? So, natay duha ka case kay consider. So, nag-lag din siya. Okay, let's take a look at this figure. So sa imong katong ganina is na-consider taong circuit na walay voltage sources. But this time around, what if naa siya mga voltage sources? Okay? So na duha ka case din he. First case is ang voltage source is connected sa reference node, kani siya, and the non-reference. Okay, for this case we have 10 volt. So kung yung nga case 1, automatic na siya if mo siya ang connection. Okay, V1 in this case is 10 volt. Okay, so kung unsa ang voltage diha nga naka-attach, 10 volt na siya. So automatic ang V1 is 10 volts. Another case is what if ang imuhang voltage source is naka-attach between sa non-reference na nodes. In this case, we have V2 and V3. Okay, two non-reference nodes. In this case, instead na i-treat siya as duha ka node separately, we can consider this as a single node. We call it a supernode. Okay? So consider siya as a supernode wherein pwede na ito i-apply ang both KCL and KVL later para i-determine ang voltage, ang node voltages V2 and V3. Okay? So we have a supernode. Oops. Okay. So we have already determined V1 which is 10 volt. Then mag-apply na ng tao KCL. Okay? Na-determine naman nato ang V1. So all we have to do now is apply KCL sa supernode. Okay? So duha ra ka node actually. We have V1 and the supernode. Sa supernode, we have still the same gihapon. So we have apply KCL at the supernode. So the currents entering the supernode kay I1 naman. Oh, napala I4 plus I4. If you look at the figure, so you have I1 here and I4. Then the currents leaving, we have I2 plus I3. Okay? Then using the Ohm's law, okay, ang imong I1, mahimo na siyang V1 minus V2 over 2 plus ang I4, mahimo V1 minus V3 over 4. So, can you follow? Para, ang imuhang I4 to na, kani siya nga direction. Kaya V1 minus V3, resistance niya is 4 ohms. Equals, na ang I2 mo is just V2 over 8. Right? Plus, ang I3 mo would be V3 over 6. Okay? So we have this expression. So ang next na dayon is we can apply KVL around sa supernode. Like for this case kani. Ang tawag KVL. So apply. Okay, we need additional equation para natay another set of equation. Okay, we have actually two unknowns here. V2 and V3. Ang V1 is known naman. which is 10 volt. So ang next nga equation na itong gamiton is kaning KVL. Kani siya. Apply KVL around the supernode. My goodness, lag. Around the supernode. Okay? So we have itong i-apply ang mga atong KVL iyang direction sa sign sa this one. So this would be positive this one. So to simplify that one, ano siya? So take a look at this circuit. Kaya siya na-simplify na siya. Okay. Ano? So dito na nga portion ng apply og KVL. So take note, i-short circuit na siya. Wala na ng resistor nga value. It's just the voltage diha, which is V2. And ang voltage diri is V3. Right? Naman siya V2 and V3. So applying KVL, we get V2, okay, minus 5 volt minus V3 equals 0. Okay, so we have V2 minus 5 minus V3. Okay, so or in simple terms, V2 is just or duha ka ano lang, we have V2 minus V3 equals 5. Okay? So we have this equation. And kaya siya nga equation sa taas, ito siya i-simplify. Kaya na-simplify mo ni siya. Okay? Simplify na siya into, here we have 1/2 plus 1/4 P1, right? Minus 1/2 minus 1/8 plus also B2 minus 1/4 okay, medyo nilag na siya 1/4 plus 1/6 okay. P3 equals 0. Okay, so we have 3/4 P1 ako na i-type ako i-pause. So we have this set of equation. Tada. So V2 minus V3 equals 5 and then can you put. So masolve na siya, we'll just be using substitution nga method. Okay? We know nga ang V1 is 10 volt and then V2 minus V3 is equal to 5 or V2 is just 5 plus V3. So yun sa substitute niya. Then we'll be able to solve the equation. So, makuha niyo ang voltages V1 and V2 and V3 of course. Okay? So, kana siya. So, So for this case, nag-consider ta og supernode because we have nodal analysis with a voltage sources naman siya. Okay? In this case, this is your supernode. Okay, so that's it for this particular na portion. The next video would be on mesh analysis. Then, compare din sa duha ka method, the nodal and the mesh analysis. So, see you on the next video.